All right, guys, so we're going to review similar triangles again, but we're just going to strictly be talking about right triangles, and then we'll have to apply that with just some application problems. But just remember that for similar triangles, the angles have to be congruent, corresponding angles have to be congruent, and their corresponding sides are proportional. So in this figure, LM and XY, if you divide those two, it'd have to be equal to MN divided by YZ, and then LN and XZ. And it doesn't matter what order you put those two in, and it doesn't matter if you were to put the XYZ triangle in the numerator and the LMN triangle in the denominator. Okay, so just a quick little overview there, just that corresponding sides are proportional. So let's take a look here. We have two triangles here, and what's really nice is that we have the right angle labeled here, so we know the orientation. So we know that if we were to turn the second triangle here to be more horizontal, that X and 7 would be corresponding sides. So I'm just going to start there. I'm going to say X divided by 7 is going to be equal to 8 divided by 14. And then I'm just going to cross multiply. So I have 14x is equal to 56. And then I'm just going to divide by 14 on each side. And so x is going to be, and then that's just it. Okay, again, over here, you can see that we have like a triangle inside of a triangle. And so if we're telling you that these two are similar, then you would know how to solve for x here. But this one's a little bit trickier because this base right here is x. This whole thing is going to be x plus 9. So when I start to write these proportionally, then that's what we'll have to put. So if I use this smaller triangle here, I'm going to say x divided by, which is the bottom part, is going to be divided by x plus 9, which is going to be equal to 15 divided by 21, because I did 15 because x and 15 are in the same triangle. So then I'm going to cross multiply, and so I'm going to have 21x is equal to 15 times x plus 9. Looks like that. And then again, just distributing here with the 15, I'm going to get 21x is equal to 15x plus 135. And then what I'm going to do is I'm going to move my 15x over to the left side so that I have all my x's on one side. So I'm left with 6x is equal to 135. And so I'll divide by 6 on each side, and then x is equal to 22.5. And that was just asking for the value of the x. If it was asking for the length of the bottom of that larger triangle, you would have to plug in 22.5 in for x and add 9 to it. But that's not what it's asking for. But just be careful, because on your skill check, sometimes it asks for x, and sometimes it asks for like a measurement or a length there. So you'll just need to pay attention to that. All right, so example 3, you can see here, this is our application problem. We have, this is a perfect example of similar triangles. So we have a flagpole and a tree is shown below, and then we have the shadow is marked here, and then they want to know the length of the tree's shadow. That's going to be our x. So we have a large right triangle right here, and we have a smaller right triangle right here. So I just like to start out with the x. I just think that that is just easier to start out with. So I'm going to have the x divided by this entire length there is going to be 15 plus x. So divided by 15 plus x is going to be equal to 6, since that's part of the smaller triangle, which is where x is, divided by 18. So what I'm going to do is I'm going to cross multiply. So I have 18x is equal to 6 times 15 plus x, and then I'm going to distribute this 6. So 18x is equal to 90 plus 6x. And then I'm going to subtract 6x from each side. And so 12x is equal to 90. And then I'll divide by 12 on each side. And so x is going to be equal to 7.5. 7.5 there. So that's the length of the shadow. And that makes sense because you can tell that the bottom part, or the shadow, should be longer than the height of our object there. Okay, and then here we have a townhouse cast a shadow. Again, perfect example of an application of these similar triangles. That's 12 feet. A nearby bicycle rack is 5 feet tall. It's a tall bicycle rack. And it casts a 3-foot shadow. So we know that the shadows should be shorter. So our height needs to be bigger than 12. So if we get something else other than that, then we know that we've done something wrong. So it's kind of another built-in check there. So we didn't know how tall is a townhouse. So I just like to start with x, or h here, because I think that's just easier. So the corresponding side to that is the height of the bike rack, which is 5. So h divided by 5 is going to be equal to 12 divided by 3. Again, I like to start with the x. You don't have to. If you always like to start with the horizontal piece or a certain piece, then you can start with that. But I just like to start with x. I think it's easier. So then I'm going to cross and multiply here. So I have 3h is equal to 60. And then I divide by 3. And so h is going to be equal to 20. And it's going to be 20 feet. So this is a 20-foot tall townhouse there. And so we knew that it had to be bigger than 12, and it is. So looks like everything went smoothly there. All right, so that's it for similar triangles with the right triangle. Again, it's really nice to have that right angle because we can tell our corresponding pieces a little bit easier. But you're just going to set the corresponding sides equal, or basically set up that proportions that equal, cross, multiply, and divide. And so now it is your turn to practice with your skill check.